So welcome everyone to our second session today. This time we talk a little bit more about a specific product instead of a whole solution. We talked about Windows Server 2016. My name is Thomas Maurer. I work as a cloud architect for a company called Untitled. We are based in Switzerland and we are focused on Microsoft Cloud technologies. You want to introduce yourself?
The only thing which is different to me is the name, Michael Ripley, and I work in the same company and we do the same shit all day.
Yeah. So this session is a little bit about what's coming new in Windows Server 2016, and you have already had some great sessions about storage, Hyper-V and everything. So we are trying to really find some really cool features which are probably not, you haven't heard about. Works fine. Okay, so first we're going to a little bit talk about software-defined storage. So probably the session you already heard. A little bit about Hyper-V, a little bit about automation, nano server, and some other stuff as well. So we'll cover a lot of things here, and Michael will begin with the storage part.
Thanks. I mean, there are so many new features and stuff coming out. We just focus on those things we are mainly focused or we are doing all day. That's why you see those topics. Of course, there are a lot of topics beside them. Clicker is gone. Software-defined storage. Who is using storage spaces in any kind of flavor? Now, 1, 2, only 2? Okay. I might know why. I can't do storage space because replication is not there. That's true. We have no replication on storage level. We do Hyper-V replica. This is really required. Asynchronous replication on VM basis. That's it. That's the fact. I want to do hyperconverged. I'm a big fan of Nutanix and all the other stuff doing hyperconverged. I want to do that. I can't do that now, so I'm not going for storage space. That's a fact. And I don't trust Microsoft. They are not really enough knowledge equipped to do storage. Who thinks Microsoft is not able to do storage the right way? Come on. Don't be shy.
No one.
No one? I won. Okay, I won.
That was a pity vote.
Yeah. Storage in Azure, of course, is not equipped. Is not done with the traditional block level SAN storage, fancy, huge appliance or system, because there is no storage system which would fit the needs for Azure. That's just the fact. So with the next version of storage, software-defined storage in Windows Server 2016, we have a bunch of stuff coming up, which was really missing. Like I said, volume-based replication, synchronous as well as asynchronous. Storage space is direct, meaning storage in your local server box distributed over a software bus. Anyone familiar with VMware, vSAN, Avarail? Okay, yeah, Sean, you don't count. Who is using Nutanix today? Okay, a few hands. Storage space direct is one answer to this. Hyperconverged, as I said, this is Hyper-V or hypervisor and storage on the same box. REFS, very interesting, come to that, and storage QoS. Current SDS stack with Windows Server 2012 R2. Really quick, shared SAS model, JBOD storage connected via shared SAS bus to multiple storage nodes. We create storage pool from all of the disks we can see from all the nodes. We create virtual disks on top of that where the redundancy layer is on the storage space, not on the pool. So we create multiple disks with different flavors of redundancy and performance flavors. Then we have the cluster shared volumes on top of that, where we create the high available SMB3 shares, where we then put the virtual machine for Hyper-V. That's the whole story. Should be familiar to anyone, more or less. And we have the SMB protocol as the storage protocol for accessing the virtual machines. So this is pretty much the same, except the fact that we have the storage not shared between the nodes, it's just local within the nodes, or it could also be connected via a JBOD, only visible to each of the nodes. So every node has its own storage. Still, we can see all the disks from all the nodes via this new component called software storage bus. The software storage bus talks about on SMB3 level, so all the nodes talk with SMB3 and exchange the data access to all the other disks which are not locally available on the node itself. We have the support for new disk types. You can now, if you like, you can use SATA disks. And also interesting, a new type of flash disks. These are the NVMe cards you plug into the PCI bus, are also supported in this model. Use case, hyperconverged, as I said, compute and storage in the same node, put your virtual machines on it, scale out as you need. Or the traditional converged setup, you have the scale-out file server composed of multiple of those storage nodes with direct attached disks. And you create this high available SMB storage on top of that, and you disaggregate compute and storage in the traditional way as the Hyper-V clusters are separate layer and they access the virtual machines over SMB3 as well. Is this, does that make sense so far? Storage space direct data placement. If we have a three-way mirror disk, a three-way mirror space on a storage pool composed of multiple storage nodes, then each of the extent is placed on different nodes. So we have a part A of the data on node 1, maybe the second part is on node 3, and the third part is on node 7. However, we always have 3 copies of the data. So if one node fails, we still are we don't are losing data. We still have 2 copies left. Requirements for storage space direct. All I'm talking about is technical preview 2, which is publicly available. Of course, things will change, but these are the facts right now. 4 up to 12 storage nodes. The size may increase. It will increase. 10 gigabit RDMA. By now, it's rocky. I'm pretty sure that the iWarp will be supported as well. A minimum of 1 flash disk per node, and supported hardware models, of course. If you want to test that, you can easily do that with virtual machines in your lab. It works perfectly. I always did that when I was not able to get the hardware for proper testing. If you talk about hardware, these are the vendors or the partners which actively take part in development with Microsoft in the storage space direct area. Yes, question?
What is this SSD being used for? The minimum
yeah, I can say that. It's a journal disk.
Okay.
So if those who know the VMware vSAN concept, you have a staging area where all the IOs come into the fast tier and then it gets destaged to this lower tier, the moving drives. Same concept.
So is auto-tiering supported? Storage spaces today supports auto-tiering?
It's not at the moment. It might be in the RTM version. It works, but it's not intended to be configured like this in this release. Well, let's have a quick look. A really quick look. This is a storage spaces direct. This one is a storage spaces direct cluster composed with 5 nodes. Each node has some disks. I faked the disks to be SSDs and HDDs. You can do that if you are using virtual machines. So you have a virtual disk presented by Hyper-V host, and some of them you tag as SSDs, some of them you tag as HDDs. And you see those storage enclosures. A storage enclosure is, in this type of deployment, it's a storage node. A single storage node is treated as a storage enclosure, and that's also where the fault domain is. The fault domain is a node. So with 5 nodes, you can easily use a single node. You can also lose a second node, because you have to have disk majority and node majority. Same rules as it applies to a traditional failover cluster. So that's all the matching. On top of that, we have the scale-out file server and the highly available shares. That's the same concept as storage spaces today. Yeah, question?
When you lose one node, the data is now replicated on 2 places.
Yeah.
If there is enough free space on the other nodes, will it start creating on the fly the 3rd copy of that data? So after some time you end up with 3 copies of the data?
If you lose what? What was the?
If you lose one physical server, one node,
Yeah, you lose some copies of data, right?
you lose some copies of the data. Will it start creating copies, the 3rd copy of the data on the other nodes? Let's say you've got 10 nodes.
You have to initiate it because the system doesn't know if it's a transient failure because you just rebooted the node or the node went away for forever. So you have to initiate a repair and then it will recreate all the copies which are missing. If you add another node which has empty disks, you start optimize storage pool, 1 command, and it gets rebalanced over the new available storage. Storage replica, we have synchronous replication on the volume level for stretch cluster. So that's meaning you can have multiple nodes spread up to different data centers, sharing a LUN on the side A, and the other 2 nodes maybe have a LUN on side B, and you replicate between the nodes the whole volume. We have a cluster-to-cluster model and a server-to-server model. It's block level based replication, but on the volume level, so it can be any type of volume, SAS, SAN, SATA, storage space volume, any type of volume. The stretch cluster, as I said, single cluster spread across different data centers. Automatic failure, you have to do nothing if you lose one side. And it's synchronous only. No asynchronous model in this type of deployment. The cluster-to-cluster model, cluster on data center A, cluster on data center B, and we replicate the volumes between 2 different clusters. You can have that synchronous or asynchronous. The failover is manually. So you have to decide now failover, PowerShell, or later on in the Azure Site Recovery Manager. Server to server, of course, single server to single server always works. The use case, well, might be limited. Of course, manual failover and as well as synchronous as asynchronous. Requirements, any volume, as I said. Important, 5 milliseconds round trip, and technically this would be up to 1,000 kilometers in theory at the speed of light, but in practice this is 30 to 40 kilometers. So RDMA NICs are required, and no, it's not required, it's recommended. You can do that with 1 gig between different sites, of course. Within the nodes in the stretch cluster, you should have RDMA for synchronous replication. SSDs for locked disks, so the area where the replicas or the replicated data is staged is also an SSD disk, and it gets then destaged to the slower disks or volumes. This is the storage cluster. Node 1 and 2 are in data center A, node 3 and 4 are in data center B. It's a stretch cluster, and it has some data in downtown, and we have a copy of the data in Santa Monica. my lab doesn't run in Santa Monica, of course. It's just I had to give a name to it. So what will happen if we lose those two nodes? As you can see, the disk, the active disk, is on storage node 1. So if we lose storage node 1 and 2, we have a split brain scenario. For that, of course, we have this new functionality, which I'm using here, called Cloud Witness. So my witness is a file share on Azure. I don't need a third data center anymore with this version of Windows Server. So now we are going to lose those two nodes. Storage node 1 and 2 will be turned off right now. And we should see the results initially, or let's say after 10 seconds. Or after 20 seconds. Don't try to refresh the failover cluster console in TP2. You will be left out with a non-responding console. Just wait up until it refreshes automatically. Demo gods and now with us. You can see that the replication here is active, and it should switch in the next few moments. Or maybe it's just a console which doesn't show me what's going on. You shouldn't do that. Are they still up and running, or? Yeah. Okay. It's not working. It's not working. It's still up and running, which can't be the case. But you should believe me that it worked. At least yesterday. The effect is the volume will automatically switch to the other nodes and will be run from the replica without any data loss, of course, because it's synchronous, and it's switching automatically back if the storage nodes are up and running again. So the last step will be resilient file system. Resilient file system is here since a while. It's not recommended or supported to be the file system for virtual machine storage. It's just for archival and let's say large file data. But this is the new file system for virtual machine storage in 2016. It has intelligent health detection and corruption, healing, auto detection of corruption. It's a file system which is intended to be online all the time. It's scalable, and we have features like we only have on the ODX level today on storage. So creating of large VHDX with fixed size is a pain today if you don't have ODX. Creating checkpoints and merging checkpoints if you have a lot of data is pain. Now with ReFast this is going to be very fast, and I think this is the only demo which will work today. I will create a virtual disk. On my local Hyper-V volume, which is a single consumer SSD. It's a fixed 20 gigabyte size of disk. So this should take, with an SSD, not more than 30 seconds. In the meantime, I'm doing the same on
Who has played with REFS before? In Windows Server 2012, 2012 R2? Okay. No one using it in production? Good.
Not that brave.
So 30 seconds more or less. The second test is a scale-up file server with storage spaces direct. The first cluster is so. Test REFS v HDX. Fixed size 20 gigs. Give it a shot and
It's there.
yeah.
Well, at least the last one worked.
It's terrible. It's terrible. You should never do demos. Yeah, really. Okay, this takes 2 seconds or 3 seconds, if it works. I'm sorry about that. It's
I
really,
will never let him do a demo again. Never.
never. I will never
Always use what it
do any demos. So this was a demo for a resilient file system.
Perfect. Normally what
Now we go to the stuff which will work as designed.
Okay, so I'm not going to talk a lot about Hyper-V because we had this great session yesterday about new features in Hyper-V and what's coming. There are huge numbers of features. I just listed some of them there, like cluster rolling upgrades. So we can now mix 2012 R2 Hyper-V nodes with 2016 Hyper-V nodes and make an upgrade. For the VMware guys, this is nothing new, but for us in the Windows clustering scene, this is new. So, and then we have online memory resize, we have hot add of network adapters, which by the way, every single VMware customer I talk to was always complaining, I can't add network adapters online with Hyper-V. Okay, now the feature is in there. We have a great bunch of new software-defined features, like a new network controller, software load balancers and features like that. And we have some of the, let's call it, storage improvements with shared VHDX files, Hyper-V manager improvements and backup improvements. So what I want to highlight are 2 features. One is security related and the other one is PowerShell related. In the most cases today, if you look at the host or the virtualization admin, we were protecting the hosts from the guests, right? So we were like looking, everyone was like concerned that some evil customer or some evil employee could do something to the VMs and could do something to the Hyper-V hosts. Today this is a little bit changed, especially with the whole cloud topic. If I bring my virtual machine, for example, to a hoster, the problem is the hoster can do with it what he wants, right? There's no way I can protect the data inside that virtual machine. And that's a huge problem for, of course, for Microsoft, as all the cloud service providers as well, but also for service providers, local service providers as well. I have worked for one, so I know that I had access to every single VMs we were hosting. So if I would try to do something bad, I could get some data, probably from banks, and sell it to German government. All that kind of stuff. So
Something like the FIFA.
something like the FIFA, yeah. It's Switzerland as well, so we can do a lot of that stuff.
That's a running gag, isn't it?
So Microsoft was like trying to fix that problem, right? So they're trying to make it harder for administrators to access that virtual machine. They also try to look out that if I put that virtual machine somewhere, I can verify that the virtual machine is running on trusted hosts and not somewhere else in some kind of like, I copied the VM and just run it on my host. It's running on that host I decided to. And then we also have, if the storage admin gets access, for example, to my VHDs, or the network admin gets access to my network bandwidth, he can access the data as well, right? So we have to have a solution there as well. So one of the solution here is a bunch of security features. The term shielded VMs is probably the overall term, but there are a lot of other terms as well. And this allows us to protect exactly virtual machines, as I said. All the problems I listed here are now with shielded VMs, we can have a solution for that. The most important thing is, of course, we can now BitLocker encrypt virtual machine disks. So in that case, if anyone can copy that virtual machine, export that virtual machine, he cannot do anything with it. He cannot like open the VHDX file, he cannot copy data out of it. Another thing is like we have this trusted host scenario. And since it's really hard to do, there are two scenarios which you can leverage. So we have to make sure that we know that this host is a trusted host, and we have two ways of doing that. First one is not using a TPM in the physical server. It's using Active Directory and the Guardian service here to make sure that the host is a trusted host. That's the thing Microsoft believes most of the enterprise companies will start to do that scenario. And then we have the second, which is probably the more secure one, which is using a physical TPM server, 2.0, inside the physical box, and make sure that, also again with the Guardian service, make sure that that VM is running on that trusted host. The problem with that is there's no TPM 2.0 chip right now in any physical server this big. There's just not, it does not exist, right? So Microsoft is lucky, probably in the Ignite session they mentioned, or one of the PMs who was presenting the Shield VM scenario was standing in the room and was telling us, if there is any hardware vendor in the room and you have a running TPM 2.0 chip, come talk to us. I was like, okay, you don't have any, but you're building the feature. Okay, whatever. So this is really cool. It's still a lot of work, and it's a very interesting topic, and you should have a look at it. The next thing is PowerShell Direct. So you can access your virtual machine over the Hyper-V host, over the VM bus. So you can get access with PowerShell inside, even if the virtual machine does not have a network connection anymore. If you, for example, if you look at Azure, if you're using your IP address or if you do a mistake on your network adapter, you can go and set it via PowerShell. This is basically the same stuff you can do. You can access the virtual machine. You still need credentials to go inside the virtual machine, so a host cannot just like go inside a running virtual machine. But if you look at that, normally you would use enter PS session dash computer name and then the name of the computer. Now you can have a new dash which is called VM name, and you can enter the VM name and run that from the Hyper-V host. Same for as other service, for example, get services, etc., etc. And also another PowerShell improvement we got is we can now name the network adapters, the virtual network adapters, with our name. For example, here it's called thread. And we can see that inside the virtual machine. So this makes it easier for us if a virtual machine has multiple network adapters to see which network adapter is which one, right? So if you're familiar with consistent device naming on physical hosts, this is basically consistent device naming for physical hosts. Then we got some Remotefx improvements. Now it supports OpenGL 4.4 and OpenCL 1.1, which is good, which is really important because right now we only have, I think it was OpenGL 1.1 or something like that.
Yeah, it was DirectX focus.
So now we have a lot of new applications around that, especially games are working on fine. Okay, we're doing a demo. I know why. No. Yeah, it's lessons learned. But we switch back a little bit to automation. So Michael will talk a little bit more about automation.
Automation in the next version is just moving forward with the journey we are all in right now. We all using PowerShell. We all using some flavor of automation. Some are using REST. Some are using orchestrators. Some are already using SMA, service management automation. With the next version of SIR, we will have a expanded set of, let's say, tooling and also APIs and interfaces to automate against the fabric or our cloud infrastructure. So, who's familiar with Orchestrator by now? System Center Orchestrator, 1, 2, 3, 4. Service management automation, anyone? No? Okay. PowerShell desired state configuration. Who has played with that or maybe already used it? One? Okay. you definitely should have a look at DSC. Desired state configuration is the new way to configure your systems. And because Microsoft is partnering with all the Linux distributions, or let's say the most important ones, they also are releasing support for Linux for DSC. They already did, so it's publicly available, PowerShell DSC for Linux. And what will follow, for example, is native SSH for Linux. We will have, is this publicly available? No, it's not yet publicly available. We will have SSH support for Windows, and if we look at the next version of Azure automation, or let's say automation in your data center or in your hybrid world, then we talk about hybrid runbook worker, which is like you're using the public Azure services, the database, the authoring features you're using on the public service, but the code is executed on your worker in your data centers. So this is the hybrid model which was introduced in just before Ignite. It's available right now. You can play with it. Also the DSC pull server, which is coming up in the next version, runs in Azure. So you have a full DSC pull server configuration on Azure. So meaning if you deploy virtual machines and you want to hook into a DSC configuration right afterwards, that would be very easy. So now you can do that, let's say with a little bit tweaking, and build your own pull server environment up there. But this is coming like a native service to be used. All the stuff I'm showing you in a minute is coming up in the next version of the portal, meaning those who attended the session this morning in Azure Stack, if we talk about the on-premises version. This is like the portal. This is the portal, how it looks like, more or less, regarding the automation framework. So as you might notice, this is a graphical editor, and those who already use Orchestrator, you will love the data bus we have there, where you can easily transfer input, output parameters and results from one workflow action to the next, or to the other. And we don't have that right now in Service Management Automation. But the data bus is back. So we have it in the next version of Service Management Automation. We have it back. So let's do a demo. Why not? Why not do a demo?
Some ads in between.
Yeah, sorry, I'm sorry about that. That wasn't planned. Portal.azure.com. If you have an active subscription, you can try that out. That's the preview of the new Azure portal, which is, in the meantime, more or less like Azure Stack will look like, or maybe exactly like Azure Stack will look like on premises. So I have my automation account here, and I'm going to create a new runbook. Add a runbook. Maybe I always use this runbook as a demonstration to shut down my Azure VMs, because my subscription is limited and capped about 150 euros. But I'm going to create a new one. Let's give it a name. Test E2E here. It's a graphical runbook type or a textual. I can choose that. I cannot change it afterwards. I'm not going very deep into what the differences are. Let's take a graphical one for now. It should be created in a second. And now we have a graphical authoring tool. It's back. Workflow script. Maybe I have already other runbooks I want to call from this runbook. Let's say hello world. First this, and then after this is finished, I will start my workflow script. What's in this workflow script? I don't know. Let's make it easy. Get the process. Not very sophisticated, I know. But I keep it easy as the demo is running nice and smooth. by now. So I have a test pane. I can save, publish it, making it active, and testing it in a test pane. That's like the orchestrator runbook tester. That's more or less what you get with the next version. All of the other stuff will resist. It's PowerShell workflow based. You will get PowerShell script execution in addition, and the graphical editor, and the PowerShell gallery, and. All the fancy stuff you are missing right now will come up with the next version. It's 2016. It's not available yet.
Okay. So next up, NanoServer. Who has heard of NanoServer before? Good. Who has tried it out? No. Oh, well, sorry. Okay, good. So when we created the slides, Michael was so kind and put some placeholders in there to make it sure what is NanoServer exactly. So we call it just the headless shit because it's a headless server.
Of course it's not shit, it's amazing stuff, but headless.
Yeah, yeah. So what's the problem today? Today, if you talk about Windows Server, right, we have some problems here, and one of them is you have reboots, and we spend a lot of time building patching solutions, making reboots more or less the way they work, that don't have any business impact, right? That's a huge effort we have to do. Server images are too big. So deploying a server, basically the most time you spend waiting for a server is copying the server image, right? And the other thing is, if you run infrastructure, you want to run the applications, right, the services, and not really like the operating systems you need, and the infrastructure just, at the moment, just requires too many resources. So, and another point here is security. You have probably seen that slide and that topics, that everywhere you get these cybersecurity things and cybersecurity problems. Sony is, for example, is one of the best examples. I will never give a credit card to them, but let's see. So we need something new, something changed. So let's see what Microsoft got now. Today we have like this kind of service running Windows Server NT, Windows Server 2003. You had one component which is basically same as the client. I think in NT, Marcus Ingrid was the guy who found that switch to make it from client to server, to make that switch and things like that. In 2012, 2008 and 2008 R2, Microsoft introduced the Server Core, the Core Edition. At that time, when we choose it for the, we had to choose during the installation, we had to choose Server Core or going for the full server. We couldn't really change it afterwards. And in 2012 and 2012 R2, finally got now one similar thing, so we can install Core and add features on top of that. We don't know, in 2012 we don't just have like 3 topics or just 2 full server and Core. We also have this minimal server interfaces, which removes, for example, Explorer and things like that, and just adds dimensional tools. That was one thing. So where is it going? So where are other problems? So one thing is, in Azure, for example, Azure has a huge amount of servers, and they're all running Windows Server 2012, and there are a huge patching involved in that. And also, if you know about the cloud platform system, one thing I left in there, they're building the whole stack in 2012 R2, right? So one number is here, if you have a fully loaded CPS, which would mean like 8,000 VMs, and if you have one patch, which does like, which requires a server reboot, you're going to have like to move 16 terabyte for that patch, right? So you can see reboots of hosts and everything like that. So what we need is a new model of server. So what they did with NanoServer, they completely removed everything out of the server. It's not like core server, you've still got a lot of tools in there. It's completely headless server, so there's no UI. If you're sitting in front of a NanoServer, you can't see anything. You can't log in, you can't do anything. That's why it's called headless.
Well, you can see a cursor which is not blinking.
Yeah, okay, you can see that.
It's not nothing.
We were talking to them to then show us at least the IP address and the name of that server. That would help troubleshooting, right? For VMs, that works great, but if you're sitting in front of a physical box and you have no clue what box this is, not really helpful. So what they designed for was 2 different scenarios right now. One is this cloud infrastructure, so Hyper-V server, storage nodes, all that things we talked about before, all that stuff. And the other thing is as an application server for this called Born in a Cloud applications. So it's not for our legacy application, it's all that kind of applications we would run on platform as a service systems and stuff like that. Okay. So I have to speed up things a little bit. So the idea behind NanoServer is that it's really like a zero footprint model. So everything I add to, I want to use in NanoServer, I have to add to the image, right? I get this plain image from NanoServer. I even have to add drivers. There are no default drivers in there. I get a default driver package which I have to add for the physical box. Even for the virtual box, I have, for the virtual machines, I have to add a package to NanoServer. I also have to add, let's say, Hyper-V features, storage features, clustering, whatever I need to make that image and then deploy that image. There's no way right now which I can online deploy features after I deployed NanoServer. Right? So I build that image and deploy it. The cool thing is I have full Windows Server driver support, so all the drivers which work with the full server or the core server are working. We have built-in multi-malware, and they're working on bringing system center management components to that system as well. So what about the management? If I can't log in, how do I manage that? So one thing is PowerShell remoting. I can remote into that. And the other thing is a web-based UI. Well, for some things, a UI still makes sense, right? So I can see things. And the cool thing is, I have some print screens here because the UI is not, right now it's not really released, but you can see it looks kind of like Azure, the new Azure portal. And in this example you see, for example, you can change the server name, you can change the IP address. This is all remote. The web server is not running on that NanoServer. The web server, if you install that somewhere and you connect, you enter the IP address or name of your NanoServer to do that, just saying. You see, for example, Task Manager. You can see here the tasks and services. And you also have a registry editor, web-based registry editor, which is pretty cool, right? Okay, so as I said, this is more for the application part. You have a subset of Win32 apps that are going to work on that NanoServer, so not everything is going to work there. You have this new core CLR base, where new applications are based on that one. You get ASP.NET 5 support, and you can run it on physical hosts, but you can also run it in VMs, of course. You can run it everywhere. Okay. So if you have a quick look at that, so this is some numbers to show how big or how small NanoServer really is. If you look at the numbers there from 2014, from the critical patches and things like that, so you would only need 3 reboots last year for NanoServer. So that's a huge difference. If you look at this, look at the normal server, you basically need to reboot every month. You've got also some security improvements, and you see that the server core, that's not even the full server, so you get less drivers loaded, less services, less open ports. It just makes it more secure. And then you have the throughput model. I just want to show you that one as well. There's a question? Yeah.
How widespread is the NanoServer? Do you know that worldwide?
NanoServer, it's not existing right now.
Yeah.
It's not this.
It's just, okay.
It's just,
well, that is probably because there aren't that many critical patches for it yet.
True,
but it
true.
probably will rise.
Yeah. They were looking at the existing patches and the new ones, and what would that mean for the NanoServer? So just one number I want to point it out. So a core server image is right now 4.8 gigabyte in size. This footprint, this is 0.4, so 400 megabytes in size. Okay, so that makes deployment much more faster. Okay, I will skip that. If you want to try NanoServer, on the new technical preview build, you have this folder called NanoServer. In there you find the image and all the packages you need to run it and try it out. And there are some more things I just want to show you, which we really want to talk about it, but it's really cool. New version of PowerShell, more desired state configuration in there, which is pretty cool, and package management. So if you remember, maybe you have heard of OneGet. So you can install packages, you can download packages and install it with your PowerShell. You have a new version of IIS. You have a feature called soft restarts. So this makes it easy. If you have the right hardware, you can do really quick reboots without initializing the hardware. And you got Windows Defender built in, and Telnet service unfortunately is removed. So that's it. Thank you very much.